Hi, and welcome to Frogcast, week 1 of the 2018 build season. So, Alyssa, what goals do you think it will be important to accomplish during autonomous?
I think first we should be able to get past the auto line because that'll give us ranking points, and then get a cube onto the scale. And by doing that, we should either be using vision tracking or the information given in the driver station to program the robot to find what side of the scale to put the block on.
Okay, tell me a little bit about this vision tracking. What would make it possibly a better route to go?
With vision tracking, we can use a camera and a light to recognize specific colors. So we would either be the red or the blue team, and say we were blue. We could use vision tracking to locate blue light specifically, and it would find the blue light on the scale or the switch, go to it, and then we can place the cube from there.
Okay, is there anywhere else that vision tracking could be useful during the game, do you think?
We could use vision tracking to locate the exact location of a cube so that we are more accurate in grabbing the cubes and picking them up.
Well, this has been very interesting. Thank you for sharing some time with us today and letting us in a little bit on some of what programming has been working on. So Jacob, tell me about some of our options as far as drivetrain goes this year.
So essentially we have 3 options for drivetrain. We have tank drive like we used last year, which if you don't know, it runs off of 2 motors on each side, and to go forward you run both of them forward, to go backward you run both of them backward, and to turn you either make one of them go forward or backward. And that makes you twist.
So two tracks of wheels that move independently.
Yes.
What else?
We also have swerve drive that we can do, and basically what it is it's a heavy drivetrain that uses independent motors so that they can all spin in whatever direction they can, so that you can slither like a snake, do donuts, and that is a very hefty robot, so it can't be pushed around as easy, so that's a plus.
So each individual wheel can move independently of all the others?
Yes.
Okay. Do we have any other options?
Yes, we have Mecanum drive, which is a very light drivetrain. It has 4 motors per wheel, and it can go very fast forward, very fast backward. And what it can also do is, if you run both of the wheels forward toward each other, it can side shift, which allows it to act like swerve drive, but not have all of the bulk.
Okay, that's very interesting. What are some of the pros and cons of each drivetrain system?
Tank drive, it only requires 2 motors for the whole drivetrain, so that's good, and it's hard to push it around.
Very simple.
Yep. Mecanum drive, it's a very light robot, and it's fast and very mobile, but it can be pushed around by other robots that can result in us not being able to climb or dropping a power cube. And swerve drive, it's a very heavy robot, and it requires a lot of motors, but it just gets you a very nice, smooth movement around the field.
Alright, so tell me what we've done so far for prototypes this year.
So this week we have done this, which is a very rudimentary design of a power cube clamp, and we have these little compliant wheels, and they are very easy to squish together. And what we're going to do with this one is we're going to leave this side able to spin like this, then we're going to put these on a belt where that they all spin off of one motor, so that we can put it next to the cube and see how well it intakes.
So this will suck the cube in and then still be grippy to keep a hold of it.
There. Yes, this will be a part of our robot. This design right here, to where it will slide open and close, it will be much smoother in the future. It's part of our robot design. This is not our finished robot. I just had to add that. So, also what we can do with this is we can take these little wheels off like that, and we can add in different materials like foam or any other type of material we want, just to see what compares differently to picking up the power cube.
Okay, well thank you for spending some time with us today and telling us a little bit of what build team has been working on this week.
Happy to do it.
So Michael, I hear that Kat has been doing a lot of research into the different measurements of the field elements. What's been the most important there so far?
The most important measurement is the height that we're going to get out of the lift to pick up the blocks, and yeah, that's our most important measurement now.
So we're working a lot on being able to reach that scale when it's up at its highest position? And what kind of methods or mechanisms have we been looking at mostly?
We have narrowed it down to the basically like an elevator lift, and it's kind of got the same idea as a forklift.
Okay. So that's our main idea.
Yeah.
And why did we choose that over other things like scissor lift, for instance?
Well, it'd be more stable, quicker, and stability is the most important thing that we're looking at.
Well, thank you for joining us today and telling us a little bit about what Tad has been doing.
Thank you.
This has been Frogcast Week 1. Thank you for joining us today.